It's Nova again, and I want to welcome you to Module 3. I hope you've been enjoying your journey through the cosmos so far. I'll be your guide today as we explore the origins of modern astronomy. The learning objective for this module is to understand how and when we learn that the Earth actually moves through space, that it is not fixed, and it is not the center of the cosmos as humanity believed for thousands of years. Modern astronomy begins when Nicholas Copernicus solves the mysterious backwards retrograde motion of the planets through the heavens. Remember when we covered geocentric cosmology? Geocentric cosmology refers to the belief that the Earth is the center of the universe. We all know that the Earth is not the center, but why did people stop believing in this idea? It was all a result of retrograde motion. Since antiquity, it has been observed at certain times of the year that some planets appear to move backwards in their orbits through the sky. This eccentricity in the planetary orbits, now known as retrograde motion, led to the collapse of geocentric cosmology. Notice in the picture how Mars appears to do a backward loop.
The planet's orbits are elliptical. So how do we explain the appearance in the night sky of an apparent backwards motion? Because we assumed an Earth-based center of the universe, this was the problem.
This drawing of Mars' orbit, shown against the background constellations, demonstrates how Mars appears to go through retrograde motion during a 10-month orbit period. So if a planet's orbit is circular, how can we explain the actual visible backward motion we observe in the night sky? In order to explain retrograde motion and still use the flawed model of the Earth-centered universe, the Greek astronomer Ptolemy invented an even more flawed view of how the planets move. The solution was something they termed epicycles. In this picture, you see a planet's epicycle as it moved along its deferent. This means the planets do loop-to-loops as they circle around the Earth, which must still be the center of the universe, of course. With the Copernican system, we have a heliocentric model with a spinning Earth that circles the Sun. It also had planets in circular orbits around the Sun. Copernicus was able to solve the mystery of retrograde motion in 1543. Let's hear what Professor Quasar has to say about Copernicus's revelation.
Understand, this was a completely radical idea. That the Earth moves and is not the center of the universe was a heretical idea punishable by death. The Earth was stationary and did not move, period. It is no wonder then that Copernicus stayed silent and did not publish his work until he was on his deathbed.
Copernicus solved the mysterious retrograde motion with the suggestion that the planets revolve around the Sun, and the distances of the orbital travel times of Mars and Earth would be different due to the different lengths of their orbit. Thus, Copernicus showed that there is actually no backward motion of the planets in orbit, and it is all an optical illusion because we could not understand that the Earth itself was also in motion, and that it also circled the Sun. Just like Professor Quasar mentioned, it is understandable that Copernicus did not publish his monumental work until he was on his deathbed. So retrograde motion of a planet occurs when the Earth passes the planet in its orbit, as shown here, because of its shorter orbital period. The Copernican model only extended to Saturn. This is because at the time only the visible, naked eye planets were known to exist in the heavens. The telescope had not yet been invented, and the telescopic discovery of an existing invisible planet was still over 200 years in the future. So now let's discuss a little about how the planets actually move. Kepler's first law states that the paths of the planet around the Sun are ellipses, with the Sun at one focus. Kepler actually created 3 laws of planetary motion, but we'll only study Law 1. E equals C over A. In math, the circle is a special form of an ellipse, whose E equals 0.
So there you have it, the first law of astrophysics. The orbits of planets are elliptical, not circular, and the circle is merely a specialized form of an ellipse, whose eccentricity equals 0. Yup, that's the definition.
The orbits of the planets are virtually indistinguishable from circles, but their centers may be significantly offset from our Sun. Notice how offset the center of the orbit of Mercury is from our Sun. In 1610, Galileo was the first astronomer to apply the newly invented telescope to observe the night sky. The telescope was invented in Holland in 1608 by Hans Lippershey, a spectacles maker. Galileo built his own telescope and was the first person credited to point one towards the heaven. Galileo's discoveries showed the importance of the telescope as a tool for an astronomer. First and foremost, by proving that there were objects in the heavens that cannot be seen by the naked eye. Galileo had some major discoveries. Click on each of the images to find out what some of those amazing discoveries were. Galileo discovered that Jupiter has moons orbiting around it. The Galilean moons are the 4 moons of Jupiter discovered by Galileo Galilei around January 1610. They are the largest of the moons of Jupiter, and their names, Io, Europa, Ganymede, and Callisto, derive from the lovers of the Greek god Zeus. The 4 moons were first sketched into his notebook. Galileo then published a full description in March of 1610. More importantly, the incontrovertible discovery of celestial bodies orbiting something other than the Earth dealt a serious blow to the then accepted Ptolemaic world system, or geocentrism, in which everything orbits the Earth. Galileo discovered the rings of Saturn with his telescope in 1610, but he could not see them well enough to determine their true nature. In 1655, the Dutch astronomer Christian Huygens was the first person to describe them as an independent disk surrounding Saturn. We now know the ring particles are made almost entirely of water ice, with a trace component of rocky material. Galileo discovered dark spots on the sun. His discovery of sunspots proved that the sun is not pure and perfect. That was alarming to the beliefs of his time. Moreover, he also showed that the sun rotates. Again, alarming. Galileo discovered the phases of Venus. Hover your mouse over the points on the timeline to learn more about Galileo. In 1564, Galileo Galilei is born. In 1610, Galileo discovers the 4 moons of Jupiter and publishes a full description in the publication Sidereus Nuncius. In 1632, Galileo publishes the book Dialogue Concerning the 2 Chief World Systems. In 1633, Galileo was sentenced by the Inquisition to imprisonment for vehement suspicion of heresy. It was later commuted to house arrest. The Catholic Church also placed Dialogue Concerning the 2 Chief World Systems on the list of prohibited books. At the age of 77, Galileo dies in Arcetri, Italy. This is a photograph of the page in Galileo's notebook where he first sketched his telescopic discovery of the 4 largest moons of Jupiter. You can also see his observation of the 4 moons on the bottom right of the page. This observation upset the notion that all celestial bodies must revolve around the Earth. Galileo published a full description in Sidereus Nuncius in March of 1610.
And if you want to know something really cool, Jupiter currently has 63 known moons. You cannot see any of them with your naked eye, but they are there. Galileo, even with the invention of the telescope, was only able to see the 4 largest moons of Jupiter. Ganymede is the largest moon in the solar system, with a diameter of approximately 3,500 miles. Io has lots of active volcanoes and is covered with sulfur. Castillo may have a water ocean beneath its heavily cratered icy surface. And Europa, which is covered by a cracked icy surface, may also have a liquid water ocean. Planetary geology is the next frontier.
In 1687, Isaac Newton publishes Mathematical Principles of Natural Philosophy. By deriving Kepler's laws from his universal law of gravitation and his 3 laws of motion, it unites the heavens and earth under the same natural laws. Gravity is a fundamental force in the sense that it cannot be explained in terms of any other force. Only 4 fundamental forces are known to science: gravitational, electromagnetic, weak, and strong. These forces are responsible for everything that happens in the universe. Gravitational forces act between all bodies everywhere and hold together planets, stars, and the giant groups of stars called galaxies. Electromagnetic forces, which like gravity are unlimited in range, act between electrically charged particles and govern the structure and behavior of atoms, molecules, solids, and liquids. The weak and strong forces have very short ranges and act only inside atomic nuclei. Gravity forces the Earth to be round because it squeezes it into this shape. A major stumbling block prevented 17th century thinkers from accepting Kepler's laws and conclusions about heliocentric cosmology. Once anything on Earth is put in motion, it quickly comes to rest. Why didn't the planets orbiting our sun simply stop also? Newton's law of gravity states that every object in the universe attracts every other object with a force directly proportional to both their masses and inversely proportional to the square of the distances separating them. The gravitational forces the sun exerts on the planets are what hold them in their orbits. Newton also realized, however, that to keep an object moving in a curved circular path requires that there be another form of force. Because according to Newton's own first law of motion, if no force acts on a moving object, it will continue in a straight line at a constant speed. Our moon stays in orbit rather than crashing to Earth because the force of gravity that holds our moon to the Earth is centripetal force. Gravity and centripetal force are the same thing. In these images, that centripetal force is provided by the string. In Newtonian mechanics, centripetal just means a force that is directed towards the center. Click anywhere on the image to see Newton's classic depiction of centripetal force. In 1781, the first invisible to the naked eye planet was discovered by William Herschel. He named this planet Uranus. William Herschel's discovery forever changed the way humanity viewed the cosmos. The heavens went from pure and perfect, with only those 5 little planet objects wandering in the heavens against the immutable celestial sphere, to the reality that there were invisible objects also orbiting amongst the constellations, which had been unknown to all of humanity since the dawn of history. This is a photograph of William Herschel's 7-foot mirror telescope that he constructed. Using this telescope, he discovered the first invisible to the naked eye planet, Uranus, in 1781. This is a portrait of Urania, the patron muse of astronomy. In ancient Greek mythology, Urania was one of the 9 muses. Urania means heavenly, and her symbols were the globe and the compass. She was a daughter of Zeus and also a great-granddaughter of Uranus. 50 years after the discovery of Uranus, astronomers ran into a problem. It seemed that Uranus was moving away from its predicted orbital path among the stars. The law of gravitation couldn't explain these irregularities, unless it meant that there was an unknown planet disturbing its path around the sun. So using the law of gravity, astronomers were able to calculate this unknown body that was causing these irregularities. This unknown body is what we now call Neptune. Neptune was discovered by using Newton's mathematical calculation method for the orbit of an unknown body. Eventually, this was verified by observation with a telescope because Neptune is also, of course, invisible to the naked eye.